So in this video, we're going to look at using the counting formulas that are in the TI-83 and 84. So often when we're calculating probabilities involving sort of more complex situations, we're going to need to employ the counting formulas. So this could include factorials as well as the permutations and combinations formulas. And so we're going to walk through an example of computing each of these. Now, the factorial is defined as this 8 with an exclamation point, and that's how it's notated. And what it means is that we're going to start with 8, and we are going to multiply our way down until we get to 1. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, in order to calculate this in the calculator without writing out the definition, we're going to use the counting formulas that are in our TI. So we're going to go to the math menu, and when you're doing this calculation, you'll first press 8, and then what we'll do is we'll go to the math menu and we'll get the exclamation point that will do the factorial operation. So it's not a fact and then a factorial function that you then put 8 inside. We're going to type 8 first, or whatever number we're taking the factorial for, and then go to the math menu. So press 8 and then press the math button, the math key, and then you're going to scroll over to the menu that is either called PRB or PROB for probability. So it's down all the way at the end on the right. And then from there, the menu will look like this. In some of the newer calculators, you may not have all of these options, but you will, in the probability menu, the list will look the same. You're going to scroll down and select this exclamation point, which is the factorial button, and then, or you can just press 4, and it will, instead of scrolling. And then when you've done that, the exclamation point will show up on the screen, and then you can press enter. And when you do that, 8 factorial is going to be calculated. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 turns out to be 40,320. Now, the permutations and combinations calculations are going to use factorials in the formulas. So our permutations formula is n factorial over n minus r factorial, and we're essentially calculating the number of different ways we can organize a certain amount of numbers, a certain amount of objects, given how many of them that we're selecting in any order. Now, they have a number of related notations. The one that's used in the calculator is NPR, where N is the number of things you are choosing from, and R is the number of items being selected. So if I am organizing, let's say, a baseball team that has 14 people on it, like for T-ball, and I want to put 9 batters into my lineup, or 9 people out on the field, the order matters. And so the order that I pick things in makes a difference. So that's going to be the permutation scenario. And they can't be in the same lineup twice, so we're not repeating any values. We're just ordering them. And so the result of that essentially is that we're doing 14p9. This would be equivalent to 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. No, wait, not 5. Not 5. Just stop at 6. So not starting at 14, counting down until you get to 9 terms. Now, that's a lot to calculate, and you could use the factorial formula that we just looked at in order to evaluate this. This would be 14 factorial in this case, divided by 5 factorial, but we can do this all in one step in the calculator. So the first thing that we're going to do is we're going to type in the 14, and then the P is going to act essentially like an operator. We're going to find that next. So we're going to go back to the math menu. We're going to scroll over to probability, and NPR is the second item in this list. You can either scroll down to it or you can hit 2, and it will come up on the screen, NPR. And then, or in the newer calculators, it will just be a P. And then you will hit 9 for the R number that follows it. So how many of them are you choosing? And then when you hit enter, as I said, it's going to calculate 14 times 13 times 12 all the way down to 6. And you're going to get this very, very large number, 726,485,760. Permutations tend to get big very, very, very quickly. Now, in combinations, this is going to be very similar. The notation that's very common can be a little bit confusing because people will sometimes confuse it with a fraction. This is very common in statistics, but in the TI uses a notation that is similar to the permutation notation. It uses NCR, C for combination. The N and the R here are the same as the N and the R here. They're just different versions of the same thing. So you may see this N over R in parentheses like this in print, but what it's telling you is you need to use the combinations formula. Now, the NCR is going to not allow for repetition, similar to the permutations case, but it doesn't care about the order of the numbers. And so that takes out a lot of different options. If the batting order, for instance, didn't matter, people could just go up randomly, or if there was no consequences of what order you batted in, then you might want to use combinations. Where this is more likely to show up are things like committee assignments, where everybody is all assigned to this committee with equal rank, or in a deck of cards where you're giving like hands for poker. It doesn't matter in the end whether you get an ace first or ace third. As long as you have the ace, you have it. So order doesn't matter, but no repetition. So an example for poker would be, we want to select a poker hand of 5 cards from a standard deck. Since order does not matter, and we cannot get the same card twice, this is a combination problem. We need to calculate the value of 52, choose 5. So there's 52 cards we're choosing from. We're assuming no jokers. And we're choosing 5 of those cards. So the way that this formula looks, it is very similar to the permutations formula, except there is this extra R factorial in the denominator. We could evaluate this by hand using all the factorial buttons, but this is pre-programmed into the calculator, so we don't have to work quite that hard. Going back to the math menu repeatedly. So again, we'll start by typing in 52, and then we'll go to the math button, scroll over to our probability menu, and then NCR is the third command down. You can either scroll down or just press 3. And then the NCR will come up on the screen, and then press 5, which is that second number, the number of things you're choosing. And then when you press enter, again, the newer calculators will tend to format this nicely. In the older calculators, you'll just see 52 NCR 5. But the answer should be the same. You should end up with 2,598,960. So even though we're choosing for many more options than the permutation case, we still ended up getting fewer options. Permutations blows up much more quickly than the combinations.